Hello students, today our topic is diode resistance. In previous session, we discussed about static resistance, dynamic resistance when diode is in forward condition. Okay, static resistance, dynamic resistance when diode is in reverse bias condition. In previous class, we discussed about static and dynamic when diode is in forward bias condition, right? Now, we'll discuss about static and dynamic resistance when diode is in reverse bias condition. We know already the definition of a static. Static resistance means what? When diode is in a DC condition, it offers some resistance. That resistance is called as static resistance. Dynamic means what? When diode is in AC condition, it offers some resistor. Diode offers some resistor. Okay, resistance. That resistance is called as dynamic. Dynamic means we need to calculate a static resistance, dynamic resistance when diode is in reverse bias condition. Okay, right. So first we'll explain about a static reverse resistance. Static reverse resistance. You know already the formula of static reverse resistance, static resistance formula, right? So here I am indicating capital RR. RR means static reverse resistance. Okay, the formula is the ratio of voltage to current. The ratio of voltage to current when diode is in reverse bias condition. So that is why reverse voltage to the ratio of reverse voltage to reverse current. This is the normal formula for static reverse resistance. But we need to calculate static resistance and dynamic resistance is from the graph. From the characteristics. What type of characteristics? In previous class, we are taking only forward characteristics, right? Now we are talking about reversal, right? So that is why we are taking reverse characteristics of a diode. So in reverse characteristics, on x-axis, reverse voltage, on y-axis, reverse current. We know already characteristics of a diode when it is in reverse bias condition. Current, very small amount of current will be flowing. After reaching breakdown point, current rises suddenly. This is the graph. Now we need to calculate static reverse resistance is from the graph. Okay. So for static calculation, we are taking 1 point on the curve. 1 point. For static, 1 point. For dynamic, 2 points. So for static, I am taking only 1 point on the graph, on the curve. So from this point, we are taking straight line on x-axis. This is the origin. On x-axis, that is A. On y-axis, that is B. Now from the graph, formula RR, capital RR equals to ratio of voltage to current, right? So from the graph, that voltage is OA divided by ratio of voltage to current, right? So from the graph, current is OB. So this is the formula for a static reverse resistance. Static reverse resistance formula, that is from the reverse characteristics of a diode, right? Next, dynamic reverse resistance. Dynamic reverse resistance. We know already formula definition for dynamic resistance, right? When diode is in a AC condition, it offers some resistance. That resistance is called dynamic resistance. Now in this condition, diode is in a forward reverse bias condition. So that's why the total dynamic reverse resistance. When diode is in a reverse bias condition as well as in AC condition, then the total resistance is called as dynamic reverse resistance. Okay. So here for dynamic I am taking the formula small rr. Small r indicates dynamic, capital R indicates static. RR is a change in reverse voltage to change in reverse current. So the formula is delta V R to delta IR. So this is the formula, normal formula. But we need to calculate the dynamic resistance from the graph. What type of graph? Reverse. Reverse characteristic. VR, IR, 0. For dynamic resistance calculation, we can take 2 points, right? 2 points on the curve. So first point, from first point to x-axis, on x-axis and y-axis, we can take the straight lines. So on x-axis that is A, on y-axis B. So from the second point also same thing, we can do same thing. On x-axis that is C, D. Now from the graph, formula is RR, small rr equals to change in reverse voltage, right? Change in reverse voltage means voltage is on x-axis, right? The distance. So change in total voltage OC minus OA. OC minus OA by OD minus OB. OD minus OB. So this is the formula for dynamic reverse resistance from the graph. So in this topic we discussed about static dynamic resistances when diode is in reverse bias condition. So that is why I am taking a reverse characteristics of a diode. Thank you.